Let's look at a table in JProCo that actually has an XML data type for one of its fields. Let's select all fields from the music history table. And we see we have 3 records and 3 fields. The first field is integer, the second field is some sort of varchar type, and the third one is XML, although the first 2 records don't have any XML data yet. Let's zoom in a little bit and just look at the record that has XML. That would be record number 3. Okay, now when looking at a table with XML in it, you can focus on all fields or just the field that has XML. And within that field that has XML, you can focus on just parts of it. Let's use an example. Let's go select just the field that we want, which is music details, and we're going to use the same criteria where we're looking for record number 3. Okay, these queries are the same except for the second one is only going to show me the music details field. Let's run that. There we go. We see this one, and of course we can click the hyperlink and expand it. And notice we have well-formed XML where the root is named music. Well, here's something else we can do. Let's have 2 identical queries. Both of them just focus in on record 3 and the XML field from record 3. But this second one is going to have a slightly different goal. It wants to take not the music root level, like the first one, but it wants to go one level deeper and take the music song level, an XML fragment, and then pull out all of that data. Here's what we're going to do. Right after the name of the field, we're going to put a dot and type query. And in parentheses, inside of the single quotes, you're going to specify, yes, I am interested in going past the music level to the song level. Let's run that. And let's see what we've got. Looks like we achieved our goal. Our next goal will be to take these 2 top-level elements and then just say, hey, give me the second one. So we're already at the music song level, but since we didn't specify which song we wanted, it pulled all of them out. Now, a first attempt to pull out the second song might be to just put a 2 right here. Well, let me run that. And let's expand our results. Yep, that works. We just got the second song, which is Manic Monday. Now, it would have been considered proper to have put parentheses around this level path and then specify the item we want. This works too, and is the preferred way of doing it. If this pulls out the second song, won't this pull out the first song? And easy peasy, yes it does. There's the first song, which happens to have 2 singers in it. Okay, now who wrote this song? Let's see. You gotta go one level deeper. The writer name element shows that it's Neil Diamond. So let's go ahead and focus in on that. All we've got to do is right after the 1, we put another slash, and we name the tag we're looking for, which is writer name. Let's run this, and let's look at our XML fragment. It just pulled out what you asked for. That last example pulled out the writer name element, which consists of a writer name beginning tag and a writer name ending tag, and the text between the tags. That's what's at that level. Now, what if you only wanted the text between the tags? Here's what you do. Let's go back to this original query. Let's auto-hide the Object Explorer so we can get some more space. And after writer name, put a slash and text, which is a function, so put in the parentheses. Now run this. Look what we get. Just the text between the tag elements. Okay, let's pull more data at a higher level. Let's pull all of the data from song number 1 by doing this. Now, I'm not going to put a parenthesis around it yet because we're going to put more items in our path. So let's run this, and notice we get the top level song and the first song only. Okay, now notice that this song has a singer named Neil Diamond and a singer named UB40. Should we pull out the first singer or the second singer? Well, since it's more recent, let's pull out the second singer. Let's go /singer, and then we'll say singer 2. That should pull out UB40. Yep, it pulls out just UB40. Now, below singer is another level, band name. So let's do that. Let's go /band name and run it. And we just get the band name. We get the band name element, which of course has a beginning band name tag and an ending band name tag and the text between them. How do we pull out just the text? Put a /text all in lowercase, parentheses, run it, and there you go. Let's go back to pulling out just the first top-level song. Let's run this, and it just happens to be that the first top-level song is number 13159. Below that, we see the writer name is Neil Diamond, the song is Red Red Wine, and the first person to sing that was Neil Diamond, and then the next singer was UB40. There's all of our data. Now, can you guarantee that as this XML is being updated, it will always have song 13159 as the first song? Or could we add a 13158 later right before it? Well, then this would no longer be the first song. It would be the second song. Then you'd have to go back here and change it. And if we added a couple more, maybe you'd have to change it again. So how, instead of pulling out the top-level element by position, how do we pull it out by its attribute value? In other words, we want to look for all of the top-level elements and scan it for just the one that has the title ID of 13159, regardless of what position that's in. Well, all we got to do there is go inside the square bracket and look for an attribute called title ID and say it's got to be equal to 13159. Let's run that. That pulls out 13159. Now let's specifically pull out 13160 regardless of what position it's in. That is the attribute value we're looking for that top-level tag. Let's run that, and we get the second song. Here's another option you're going to want to know as far as using the query method and pulling out XML. Let's declare a variable called @book, and we'll declare it as XML. Now, we'll set this book equal to a specific book. Let's put in the format, and let's have another format, so it's 2 formats for one book. Now, this is going to be an XML fragment. There's no root, which is okay because the XML data type can handle that. Now, what's the format of this book? Well, we're going to do paperback, and we're going to do Kindle. 2 formats for the same book. We're going to say the paperback price is $25, and the Kindle price is $7.99. Let's make sure that this is well-formed or at least a valid XML fragment and that it runs. Okay, excellent. Now, let's select @book to see what we got. Here's the XML. And there we go. We can see it in our window. Now, we want to pull out one specific one. Let's pull out just the Kindle book by going Query, and then in these quotes, we'll put a /, and we'll choose Format, and then we'll choose the attribute. Now, notice we have an attribute called Style. We want the style of Kindle. So we'll put @style equals Kindle. Okay, give ourselves some room. Okay, let's see if this runs. Okay, that only pulls out the Kindle book. All right, now what my goal is to pull out the price of the Kindle. Now, I don't want to pull out the word Kindle. I want to pull out the price of the Kindle. So I'll put a set of parentheses around this path. And then we're going to ask for the attribute price. In other words, we're searching on the attribute of Kindle, but what we want to see is the attribute of price. We run that, and it says, attribute may not appear outside of an element. Okay, so what are we going to do about that? How do you search for something and get the thing next to it that you're searching for? All we need to do here is put the word data. Data is a clause. So we want the data of price, while we're searching for a Kindle value. Let's run that, and we get $7.99. Let's do that query with the data option using a table. Now let's create a very simple table called books. And all this is going to have is a book name, which will be varchar 25. And then it will have a price. We'll call a field pricing, which will have the price for the Kindle and paperback. And we'll declare that as XML. Let's run this. Commands completed successfully. That's great. Now let's insert into books the following values. Well, it's got two fields, so it's going to need two values. The first value here will have the book name, and the second one will be our XML. So this first book, let's call it Joe's to Prose Volume 1. I just pasted that in there. And the next one is going to say that the Joe's to Prose Volume 1, the paperback price is $25. The Kindle price is $7.99. Okay, let's insert that. One row affected. Very good. Now, let's insert into books the following values. Okay, I'm going to have two different values since there's two fields. And let me paste in Joe's to Prose Volume 2. Okay, and that's got a different pricing structure. It's a bigger book. That one sells for $39.99 on paperback and $9.50 on Kindle. So let's run this. One row affected. Okay, great. Let's look at the data inside of this new table. There's books, and I'm just going to say edit rows. And there's Joe's to Prose Volume 1 and Joe's to Prose Volume 2, and there's the XML inside of it. There's our two records. Okay, now remember, what we want to do is we want to pull up the Kindle price, or in this case, we're going to pull out the price of every Kindle book. In other words, we're going to see the Kindle price for Volume 1 and Volume 2. So let's start writing our query. Let's go select all fields from books. Now, let's just make sure that this query works in a simple form. Okay, here's the XML for the first book. Here's the XML for the second book. Great. Okay, let's narrow it down to just the Kindle books. Well, let's get an itemization of our fields. Let's say book name, and then the XML field, which is called pricing, and we're going to say dot query, and in the set of parentheses and single quotes, we'll put our XPath. Now, let me start off by putting a parenthesis in there right away, and inside of there, I will say format is the attribute style, which is equal to Kindle. Okay, let's see what that looks like. Let's see if we get just the Kindle. Yep, it's showing me just the Kindle for book 1, and it's showing me just the Kindle for book 2. Great. Now, I don't want all that XML data. I just want the price of the Kindle book. Okay, so there's a couple things we got to do. Number 1, we have to specify price. Now, if we leave it right there, it's going to tell us, hey, you can't have an attribute appear outside of an element, because it doesn't realize what you're looking for is not what you want to show. You just want to show the relative price of what you're searching for. So let's put the word data. Data with query tells us that the second attribute is the one we want based on the searched attribute of the path. So let's go ahead and run that. And we see Volume 1, $7.99. Volume 2 is $9.50. Time for Lab 5.2, Skill Check 1. Pull out title ID of 13159 from the music song level regardless of the order it appears in the XML field. Pull out the second singer for this song. When you're done, your result should resemble the figure you see here. Skill Check 2. Pull out the second record from the Olympics table and show the XML from the O Details field. Skill Check 3. Pull out the second record from the Olympics table and show the XML from the O Details field. show the XML fragment from the first top-level element event in the XML data. Skill check 4. Pull out the second record from the Olympics table and show the XML from the O details field. Show the XML fragment from the gold medal element under the first top-level event element in the XML data. Use the text function to pull out just the text field from Skill Check 4. Skill Check 6. Pull out the second record from the Olympics table and show the XML from the O details field. Show the XML fragment from the bronze medal element under the event with the event ID of 002. And that will do it for Lab 5.2, XQuery. What do we got next? It's time for Chapter 6. Let's do Lab 6.1, XML Data Type Methods.